In this video, we are going to finish our discussion on divisibility rules, looking at the divisibility rules for 3, 6, and 9, and then also looking at some rules we can use for other numbers. All right, first let's get the divisibility rule for 3. A whole number is divisible by 3 if and only if the sum of its digits is divisible by 3. So if you think back to when we did the divisibility rules for 2 and 4 and 8, we did not necessarily look at the whole number, we just looked at the last 1 digit or 2 digits or 3 digits. But for 3, we have to consider the entire number. We have to add all the digits. Interestingly, the same divisibility rule will work for 9. If the sum of the digits is divisible by 9, then the number itself was divisible by 9 to start with. Okay, let's experiment with these. So let's look at the number 1002. I want to know if the number 1002 is divisible by 3 and 9. So 3 first. I'm going to sum the digits, 1 plus 0 plus 0 plus 2, and I get 3. So does 3 divide 3? Yes, 3 goes into 3 one time with a remainder of 0. So because 3 divides 3, and the sum of these digits was 3, then I know that 3 divides 1002. If the sum is divisible by 3, then the number itself was divisible by 3. All right, and the same thing is going to be true for 9. So does 9 divide 3? No, 9 does not go into 3 with a remainder of 0. So therefore, 9 does not divide our original number. All right, now notice, just like we talked about in the last video, just because 3 is a yes, 3 divides 1002, that doesn't necessarily mean 9 is going to be a yes. In this case, 3 was yes and 9 was no. But if 3 had been no, if this number had been something that was not divisible by 3 to start with, so suppose that it was 1001, right? If this was a 1, then the sum would be 2. Does 3 divide 2? Well, the answer to that is no. So therefore, 3 does not divide 1001, which means automatically that 9 does not divide 1001 because 9 is a multiple of 3. So if 3 is a no, 9 is automatically a no, but if 3 is a yes, 9 may or may not be a yes. Yes does not carry, but no does. All right, let's try another one. So this time I've got 14,238, and I want to know if that's divisible by both 3 and 9. Okay, so sum the digits. See what you get when you add those digits. Well, hopefully you got that the sum of the digits was 18, and 3 does divide 18. 3 times 6 is 18. 3 goes into 18 6 times with a remainder of 0. So because this is true, I know that 3 will divide my original number. Okay, how about 9? The sum is 18. Does 9 divide 18? Yes. 9 goes into 18 twice with a remainder of 0. Therefore, 9 divides 14,238. So in this case, 3 was a yes and 9 was a no. In this case, 3 was a yes and 9 was a yes. So sometimes they will both be yeses. Sometimes the first one will be a yes and the second one will be a no. But remember, if the first one is no, every multiple of that number is automatically a no. All right, let's look at 6. So the rule for 6 is a little bit different. In order to tell if a number is divisible by 6, then it must be divisible by both 2 and 3. So if this is true, and I promise you that it is, why can we not say that if a number is divisible by 2 and 4, then it's divisible by 8? Isn't that the same thing? 2 times 3 multiplied to be 6, 2 times 4 multiplied to be 8. How come that rule works here and not here? Well, let's look at the numbers that we have. Look at 2 and 3. Do they have a common factor? Yes, they do. Their only common factor is 1, because 1 divides everything. So 2 and 3 are both divisible by 1, but they have no other common factor. How about 2 and 4? They are divisible both by 1, because 1 divides everything, but they are also divisible both by 2. So these have a common factor other than 1. So therefore, I can come up with numbers that are divisible by both 2 and 4, Both of these are yeses, but it is not divisible by 8. 8 is a no. Because 2 and 3 don't have any common factor except 1, then if 2 and 3 are both yeses, 6 is automatically going to be a yes as well. What we have just done is what is called relatively prime. So two numbers are relatively prime if they have no common factors other than 1. So 2 and 7 are example of relatively prime numbers. They have no common factor other than 1. So if a number is divisible by both 2 and 7, what can we say about this number based on what we were just talking about? So what I'm saying is I have this number A. 2 divides A, and I also know that 7 divides A. 2 and 7 are relatively prime. 2 times 7 is 14, so I know that 14 divides my number A. As long as the two numbers are relatively prime, then whatever their product is also going to divide the number that you have. All right, notice it does not say that the numbers have to be prime themselves. It just says they have to be relatively prime. So for example, let's look at the numbers 4 and 9. I have 4 and it divides this number B. I also know that this number B is divisible by 9. 9 divides B. Well, 4 and 9 have no common factors other than 1. They are relatively prime. Even though neither one of them are themselves prime, they are relatively prime. So therefore, 36 will divide my number B as well. So we're going to talk about prime numbers more in class, but I just want to emphasize the fact that relatively prime has nothing to do with whether the numbers themselves are actually prime. It just means that they have no common factors other than 1. Okay, so using all of this logic, what might we say for a divisibility rule for 35? All right, I have this really long number and I want to know if it is divisible by 35. Well, 35 is equal to 5 times 7. It is the product of 5 and 7. 5 and 7 are relatively prime. They have no common factors other than 1. So therefore, my divisibility rule for 35 could be if a number is divisible by 5 and the number is divisible by 7, then I know the number will be divisible by 35. So you need to be able to do this two different ways. First of all, like this. If I give you two relatively prime numbers, you should be able to tell me that their product will divide into whatever the number is that I'm looking for. And if I ask you for a divisibility rule for a number like this, you should be able to break it down into two relatively prime numbers and tell me that these two numbers multiply together to be this one. They are relatively prime, and so therefore, if a number is divisible by this number and this number, it's divisible by my original number. So two different ways of looking at the divisibility rule here, which you need to be responsible for. Okay, last, I told you guys I would tell you what this would look like on a test. So for a test question, I might have a very long number like this, and I would say determine if it is divisible by each of the following, and I would also ask you to give me a reason. Okay, so let's do that. Let's look at this number. Is this number divisible by 2? Yes, it is. Remember, for 2, I only have to look at the last digit, and if that last digit is even, then the number itself is even, and therefore it is divisible by 2. Okay, same number. Is this number divisible by 3? Well, in order to answer that question, I would need the sum of the digits. The sum of the digits in this case is 60. And if this were a test, I would expect you to tell me that on the test. The sum of the digits is 60. 3 divides 60, right? 3 will go into 60 20 times with a remainder of 0. Therefore, yes, this entire number is divisible by 3. All right, how about 4? Well, for 4, I have to look at the last two digits. I probably do not know my times tables all the way up to 84, but I can divide that. 4 goes into 8 two times, 4 goes into 4 one time. 84 divided by 4 is 21. So because 84 is divisible by 4, then yes, that whole number is divisible by 4 as well. All right, how about 5? For 5, I just look at the last digit. That number is not a 0 or a 5, so therefore, no, this number is not divisible by 5. Okay, so 6 is one of our new ones. What was the rule for 6? Remember, for 6, 2 and 3 are the ones we look at. 2 and 3 are relatively prime, and 2 times 3 is 6. 2 is a yes. 3 was a yes. Therefore, automatically 6 will be a yes as well. Okay, 2 is a yes, 4 is a yes. Does that make 8 a yes? Not necessarily. Maybe it will be, maybe it won't, but 2 and 4 are not relatively prime, so we cannot use that logic on this one. For 8, do you remember the rule? The rule for 8 is I have to look at the last 3 digits. Well, I have no idea if 8 divides into that number or if it doesn't. So let's divide it out and find out. So I will do 584 divided by 8. Okay, so 8 goes into 58 7 times. It's 56. 24. 8 goes into 24 3 times. I'll just move over here because I'm out of space. With a remainder of 0. So the important thing is not necessarily how many times it goes in. The important thing is that I have a remainder of 0. So that means 584 is divisible by 8, which means this entire number is a yes. That whole number is divisible by 8. Okay, so let's do 9. Well, 3 was a yes. Does that automatically mean 9 is a yes? Not necessarily. Remember, yes does not carry. So the sum of the digits, we added those up before, and the sum of the digits is 60. Does 9 divide 60? Maybe I'm not sure. Maybe I'm not really comfortable with my 9's times tables. So I'll just add those digits again. What's 6 plus 0? 6 plus 0 is 6. Does 9 divide 6? Well, the answer to that question is no, which means that 9 does not divide 60. And if 9 does not divide 60, which is the sum of these digits, then 9 does not divide this number. The answer to that one is no. All right, how about 10? Does it end in a 0? Nope. So therefore 10 is a no as well. So when you do this on the test, be ready to write yes or no, but also be ready to justify your answer. You will actually get more credit for a good justification than you will for the correct yes or no. So that's why for 3, it's really important to tell me what the sum of the digits is. If you accidentally make an addition error and you add this together to be 62, then your answer for 3 would be no. But if all you tell me is no because it doesn't go into the sum, I don't know what you got for your sum, so I can't tell if you're using good logic or if you're not. So please make sure you tell me exactly what you got for the sum of the digits when you do this kind on the test.